in machine learning in Gloucestershire University. Yeah. My project or paper about cyberbullying detection using self-attention convolutional layer. Okay. Basically, can you hear me? Hello? Can you hear me?
Yes, I hear you.
Okay, brilliant. So basically, okay, so I work for the health ministry as well, hospital, and we had a problem with okay, so we had a lot of patients suffering from bullying in social media. Yeah. And they start looking at a solution to stop cyberbullying on Twitter, especially. Yeah. And they asked us as an IT team to look at a solution. And we start looking at all existing systems. And we found lots of people start looking at, or researchers start looking at machine learning. Yeah, as a solution. But machine learning didn't give high accuracy. It decided to go to deep learning. Okay, and they still have the same problem. After that, they looked at combining machine learning and deep learning. But the hybrid model, this combination didn't work as well. So as a team, we start looking at what is the problem and how we can solve it. And one of the problem is that the machine learning doesn't work really good in feature extraction or understanding the the tweets in the Twitter, and get this problem solved by finding the main keywords or the keywords who affecting the results. And then they decided to add deep learning to support machine learning with the decision, with extracting or analyzing the tweets and looking at the tweets which is affecting people and bullying people and stop them before go into the system. So we were looking at a couple of machine learning and deep learning. The first two machine learning, which is logistic regression, and the second one, random forest. Yeah, and the other and the deep learning were the convolutional model and LSTM. So I will explain about each one. So logistic regression actually is based on a probability. So we'll look at the tweets and see the probability and see how probably affects people and how bullying it is. The random forest consists of lots of algorithms, yeah, and these we pass the data to these algorithms, and then the algorithms start analyze the data, yeah, and give an output. Each algorithm, after that, we will look at all the outputs, and then we choose the best one Yeah, but what is they recommend to combine something to that, to the probability and the analyzing, which is a model good in feature extraction and analyzing tweets before you pass it to the model or the classifier who decide it is Boolean or not. So they decided to use a CNN, yeah, which is control network. It's really good in feature extraction, but the problem with it is only extract the local features. It doesn't extract global features. It doesn't focus on global features and forgot features. More the model extracts features, more forget about the feature extracted previously. So they decided to support it with an algorithm called LSTM. LSTM, basically an algorithm, take the data and read the tweets and understand it. When it passes to the next stage to classify it, if it's Boolean or not Boolean, it will memorize it. To memorize and save the main keywords, or which is the main or the most Boolean keywords memory, yeah, and then use it later. So the CNN, forget that. It only focus on the keywords, on the local keywords, and forget about the global. But even with that, with LSTM, the accuracy was really low because of the mechanism. So longer, you know, when the text get longer or the tweet get longer, LSTM can't cope, can't put on with. So they invent something called attention layer. Attention layer basically will look at the text, yeah, and give each keyword a weight, yeah, and put it on a table. So each word will have a weight based on its importance, yeah. So and we'll put each word against each word a weight, and based on that, the outcome will be affected on the weight, not on the context itself. So what CNN will do will analyze the text and find the keywords, yeah, and straight away the attention layer will give each keyword a weight, and in the end, in the output, we'll look at which words have a high weight and calculate it. If it's really high, that means it's Boolean. If it's not, it will be not Boolean. And hello, and if you can see the slides, the first step before we pass the data to the model, we have to clean the data. We have to get rid of all the data or the words not important in the text or doesn't affect or make it Boolean or not. So the first thing, we will get rid of all the stop words and turn the words to its roots first. Then we'll pass it to something called PCA. PCA actually, it reduces the dimension of the tweet, and by drawing a line and relate all the keywords to the line. And after that, it will have a clean data, and this data, it will be to training and testing. The training normally be 70%, and test data for the test will be 30%. Yeah. Then we pass these data to the model, and the architecture of the model is here. So basically, what we do, firstly, we will pass the data to the convolution layer, and let the convolution layer analyze it and extract the feature, and then pass it to the attention layer. Yeah, to convert the keywords to vector and give each keyword a weight. And we'll pass again these data. After that, we will pass it to the another convolution layer. The convolution layer, it will extract the features again and pass it to the attention layer. The attention layer, it will convert again the data or the keywords to a vector, and then give each word again a weight and calculate the weight and pass it to the next layer until we get the output. And after adding this, after the attention layer to the model, we got a really high accuracy. It was the highest accuracy between the other model among other models, which is 97%. Yeah. And I compared the results with previous researchers results. It was the highest among them. The problem we faced, actually, because we are using data, already data, okay, data sets, which is sometimes the model get used to it and find it easy to find which one Boolean, which one not. But when we pass a real data, real-time data, the model struggle, and it will be the next step for us to work on. Hello? Hello?
Yeah.
Okay. I'm sorry, the slides, I don't know, I'm not sure. I want to go through them one by one, but